In exercise 3D, we want to talk about the marginal impact of features in random forests. How do we actually derive the marginal effect of features on the target variable in a random forest? So as you might remember, we cannot compute simply derivatives of the trees, and especially not of random forests. So if you think back, this was the reason why we had to optimize the regions in the trees the way we did it with this separating method, the top-down greedy approach. And so we cannot use the derivatives. Alternatively, we can use this following function that you know from the lecture. So what does this function actually describe? It describes the marginal effects of the jth variable, of the p variables that we have, so the features. Now, what does this actually describe? Well, x here is actually a variable in the sense that we will use it as a range, and we will do the following. We will now plug in one of the predictions, one of the observations that we have, and use all the values for the features for that very prediction. Just plug them in, except for the variable x here, so the jth variable. This we will leave out, and we fix all the others, and then we will use 100, let's say, or 101 different values, so from 1 to 100, let's say. So this x will be the range between 0 and 100, or whatever range is feasible. And then we will calculate for this one observation the prediction of the random forest using this observation, or the values of this one observation that we took from our data set, and all the 101 values for x. Okay, so we plug 0 in, and all the other values from the first observation will be fixed. Then we make the prediction, then we plug in 1, with all the other values from this one observation still fixed, and make the prediction and go on until we have reached 100. And then we will do the same for the next observation and the next observation and the next observation until we have all the observations, all k observations, and then we will average over the k observations, and we will get a value for, or a prediction value for every value of x that we've used in the range here, and this will be our marginal effect of the variable x then, okay? So we will plug in every observation, make a prediction for 101 different versions of x for every observation, and then we will average over the observations to get a prediction value for every value of x here in this range from 0 to 100, and this we can then plot as the marginal effects. So xj here could be, for example, a variable, let's say age. I don't know if we have it in a data set. But it could be basically any predictor. So let's say, for example, for the variable xj. We now have the observations k1 to k capital K, and then we will plug in the values of the features and make our first prediction where we set xj to 1. And then we will just plug in again of this first observation all the values for the features except for xj, and we set xj equal to 2 and make the prediction. And then we will move on until we've reached fxj equals, in our example, 100. And we will continue this for all the observations, so k times. So here for the kth observation, we will also do this. So we have basically all these observations now, and now we average, but we won't average here over the 101 different values of x. We will average over the k observations. And this will lead us, so we average over those. Let me get another color. And then we'll have for every of these values from, oh, I forgot 0, so maybe 0 should have been the first one, but you get what I meant. So for every of the values in this range from 0 to 100, we will get an average over k of the predictions. And this will lead us to our marginal effects function here. Because we basically know now what will happen if we increase the value of this feature xj by one marginal unit. We will know what the effect will be on average over the whole data set.